Riemann sums
Yep.
do not evaluate the limit. So it's not really hard at all. It was more, so in parentheses it says use the right endpoints of each subinterval as your sample point. My question was, like, how do you determine the right endpoints for a problem like this versus the left ones? So I'll give you the integral, and then maybe you can, like, maybe I can better explain what I'm looking for. But
Sure.
So it's the limit from the lower limit is 3, and the upper limit is 6. So yeah, 3 to 6, and then x over plus x dx.
Good?
Yep, it just wants it as a limit of Riemann sums.
Right. So this is the same with the limit as n approaches infinity from n from I equals 1 through n. And this is delta x times f of xi. Well, delta x has to be 6 minus 3 over n. That's the definition. B minus a divided by n. So this is 3 divided by n. So this piece is 3 over n. Now, obviously this piece must be f of xi, right? So you can determine xi as being 3 plus I delta x. So that is 3 plus 3I divided by n. So this function is the original function, right? So with xi in it. So you can write this as xi over 1 plus xi to the fourth. It can also be written as the same piece, this piece I'm talking about. You can write it as 3 plus 3I over n, everything divided by 1 plus 3 plus 3I over n to the fourth power. This is f of xi. So the limit would be the limit as n approaches infinity from the summation, the sum of from I equals 1 through n. Delta x is replaced by 3 over n. All this is this, but in terms of xi, when you replace xi, you get this, because xi is 3 plus 3i over n. So I replaced xi at the top, and I replaced xi inside. I think we looked at this problem, but maybe I'm mistaken. So now the question, Brian, is what again? We're asked to find. So no, your question is, okay, so in the limit of the Riemann sum, what do I use? The leftmost point, the rightmost point, or the midpoint, right?
Right.
And here's my answer. Here's why. Who cares? It doesn't matter. Use whatever you want. Once you have n approaching infinity, they are so close to each other that they are the same point. The leftmost point, the rightmost point, the midpoint, they are all the same. Because of this.
Okay.
That's why we call this xi. Who cares? So you are correct. Your question is perfect. So this is one subinterval. If I use the leftmost point as this, for the height, right? If I use the rightmost point, here will be the height. If I use the midpoint, this will be the height, correct?
Right.
So this is from, let's say, xi, and this is for xi plus 1. So is xi here? Is xi here? Or is it xi here? Do I use the leftmost point? Do I use the rightmost point as the height? Or do I use the midpoint? The question is perfect, but who cares? They're infinite. So these 3 points are so close to each other, they're probably the same.
Okay. Yeah, it just because in the problem when it said to use the right endpoint.
Yes, but only when we have a finite number of intervals. Excellent question. If you tell me that n is 4, there is a huge difference. If I use this, the height here, or the height here, huge difference. But if I have n and goes to infinity, nobody cares anymore.
Great. All right. Thank you.
Actually, potentially even from starting from n equals 16, nobody cares anymore. Because they will be so close. N equals 32, they will be probably almost the same. And from that point on, I will probably always get the same number, almost. But it's a perfect question. But when n approaches infinity, right, we have n subintervals, like a million. And then this million goes to infinity, nobody cares anymore. These are so close to each other, they are all the same point. Perfect question. In 24 years of teaching, no one asked that question. I said it several times and I explained that, but actually you're the only one who asked that.
Great. Well, I'm glad to hear.
I was so happy to write this. Thank you.
Yeah, no worries.
Because you understand why. 4, yeah, it makes a difference. 16 makes a difference. But starting from this on, too close to even tell the difference. And when we get to infinity, nobody cares anymore.
Okay.
Because we are so close to the truth that this one is identical. The area is identical with this. But this we cannot determine for such a function.
Okay. Yeah. So even if the problem said use the left endpoints of each subinterval as your sample points, then it wouldn't even matter.
No.
Okay.
But we can, for this one, we can determine the exact area. Let's do it. So the integral from 3 to 6 from x dx divided by 1 plus x to the 4th. Any suggested substitution? Well, this one is a little bit harder because the substitution we have to use is x squared. And here's why, because du equals 2x dx. X dx, nice. What I don't have is 2, but 2 I can always make up. This is du. Do not copy the limits of integration. The numerator is du. Can anyone give us the denominator?
Would it be 1 plus u squared?
Excellent, well done. When I plug in 3, I get 9. When I plug in 6, I get 36. Which function prime is 1 over u squared?
Is it arctangent?
Yes, our best friend. Awesome. I plug in 36. Minus arctangent 9. Done. I don't know these numbers, but I can determine it. Plug it in the calculator. Very good question. Thank you so much for bringing that.
Thank you. I Actually, I had another one
Yes.
from the same section.
Yes, please.
It's kind of interesting the way it works out because it's a semicircle that you have to calculate, I guess, the integral for. But so mine was the integral from -1 to 0. So it's the quantity of 5 plus the square root of 1 minus x squared, all of that times dx.
Now, always remember, I want to go back for a second. Every time you're asked to find a definite integral, you have to make sure that this function is continuous. So 4 plus 5x is always greater than 0 on this interval. And it's never 0 on that interval. At 0 will be 4, and at 9 is 49. So careful of that. I just want to re-emphasize that. I went ahead and did it without dimensioning. The same thing here. This function is defined absolutely everywhere. 1 plus x to the 4th is never 0. No problems between 3 and 6 and everywhere else. So always remember to check that. Same thing here. This function requires 1 minus x squared to be greater than or equal to 0. Multiply by -1 and x squared minus 1 less than or equal to 0. X minus 1, x plus 1. Remember, you cannot take square roots in an inequality. Please do not try that. And if you graph this function, or you can study the sign, remember it's x squared minus 1. So this is less than 0 between -1 and 1. Perfect. Between -1 and 1, the function exists. It's fine. Okay then, so, because otherwise I would write FTC not applicable and I'm done. And now I have to use a substitution. And in this case, we don't really know how to handle this, to be honest. But if we graph it, then we are going to find the area. Because I can find the antiderivative of 5, which will be 5x, but I don't have a function whose derivative is this. I can't determine the antiderivative. I don't know which section this comes from, but it cannot be 5.5. Because we can't use the substitution here. The substitution that you will have to use will be in Calc 2, and it will be a trig substitution, in which x will be defined as sine t, and then 1 minus sine squared will be cosine, and from there it's very easy. But not in this class. Does it come from 5.5? I doubt. It can't.
Yeah, no, it's from 5.2.
Correct. Yes. So we can't really determine that. So here's what we're going to do. I will graph this, which I already did, but only between -1 and 0. So it's only this piece. Right? Also, yes, you can graph it as thinking of in terms of a circle if you square that, right? And then plus 5. So let's just look at that. So the square root of 1 minus x squared is let me write this first so you understand what I'm trying to do. So let's say y equals the square root of 1 minus x squared. And when we square both sides, we get y squared equals 1 minus x squared. When we add x squared, you get x squared plus y squared equals 1. And this is a circle with center at the origin with a radius of 1. So this will look like this. But this is basically the square root of 1 minus x squared. So it's not the entire circle, right? So this piece is the square root of 1 minus x squared, but this piece is negative the square root of 1 minus x squared, which is we don't even need. So this piece is this graph, but I also have the 5 in front. And also I have to keep in mind that the integral happens only between -1 and 0. So I'm not interested in this. I'm interested in -1 to 0, moved up 5. So coming back to my graph, 1, 2, 3, 4, 5, -1, and it goes up to 1. So this is the integral, and this is the area in question between 1 and 0, and this is 5, and this is 6. So I have this piece, which is a rectangle 1 by 5, base times height, this is 5, and this is the area of a quarter of a circle with a radius of 1. So just this piece is 1/4 of a pi r squared, where r is 1. So that is pi over 4. So finally the answer to the integral from -1 to 0 from 5 plus the square root of 1 minus x squared dx is pi over 4 plus 5.
Perfect, thank you. Yeah, I was confused because
Yeah, we cannot determine this integral till Calc 2, in which we will use what is called a trig substitution. So any questions?
nope, thank you for going over it though.
Sure. So yeah, I have to do it in a roundabout way. I'm even thinking that when I use the substitution x equals sine x, then I have cos sine x dx. Yeah, so even that I may have to run into some difficulty there. Right, so the cosine x, oh no, that's a simple situation with it, yeah, the trig, yeah. It just changes into du, yeah. Any questions other than this? Very good, excellent question.